B is the only solution to x squared minus 9 equals 0. Put your thumb up when you think you know whether that is true or false. Right, looking for those thumbs. Again, this should be something that you don't have to graph, you don't have to calculate with like a calculator. Look at it. It's 3, the only solution. True or false. All right, Lana, what do you think? So there's no other number that could make this true. There's no other number that when we square it and subtract 9 will also get 0. All right, Wade. So -3, if I were to plug it in. Class, what's -3 squared? 9. And if you're thinking -9, well, you should never square a number and get a negative. So if you're getting -9, that's probably because you're using a calculator and you're not using parentheses like you're supposed to. Because -3 squared is also 9. And 9 minus 9 is 0. So this is actually false because there is another solution, and the other solution is -3. -3 is false. Right. Last Friday, we solved problems like this algebraically because there's just one x in there. You can isolate it, starting with what's farther. So what's farther from the x, the 2 or the 9? How do you cancel out subtracting 9? And we're going to do that to both sides of the equal sign. I get x squared equals 9. Opposite of squaring is whatever you do on one side of the equal sign. So then I get that x equals, and we are trying to get you to remember, anytime you're square rooting now, put a plus or minus. Because really it can be the plus and the -3. There's 2 answers there. Good on that? All right, well then here's the next one to try and do in your head the best that you can. A solution to x squared plus 25 equals 0 is -5. Put your thumb up when you think you know whether that's true or false. That a solution to that equation is -5. Okay, Chris, what do you think? All right, so solutions are values for the variable that make it true. So if I were to plug in -5, and that I do think you could do it in your head, but let's see. Class, what's -5 squared? Say it louder, -5 squared is, and that's a positive 25. Because like I said, you should never square something and get a negative. So if you did it in your calculator, you must have left off the parentheses, and that's why it's reading it wrong. And then we know that 25 plus 25 is not 0, it's 50. So that actually makes this false then. So it's false And if we were solving this algebraically, so like undoing what's being done, how would I cancel out that 25? So we subtract it on both sides of the equal sign. I get x squared equals negative 25. Opposite of squaring is, and this is why it's not a solution, is because there's actually no solution for this one. Because what they have here is square rooting a negative number, and that's impossible. If you try to do that in your calculator, it'll give you an error message. So, it's false because the solution to this is actually that there is no solution to this equation. Good on this one. Well, then the next one, put your thumb up when you think you know whether it's true or false. X times x minus 7 in parentheses equals 0 has two solutions. True or false? Put your thumb up when you think you know. Okay, Blaine, what do you think? Do you know what the two solutions are? Okay, good. And so that should have been able to be done in your guys' heads because in the last unit, we practiced, even with flashcards, if you remember, how to identify the x-intercepts when it's in factor form and set equal to 0. So when it says solutions, well, solutions is another word for zeros. It's another word for x-intercepts. And we also learned the zero product property last Friday. You're basically figuring out what x has to be so that when I multiply the x times the parentheses, that it equals 0. So 1, if x is 0, that makes it true. And then if x is 7, 7 minus 7 is 0. So that's the other one. Yes, two solutions, that one's true. And in our last one for the warm-up, we have 5 and 7 are the solutions to this equation. Put your thumb up when you think you know whether that is true or false. Okay, Wade, what do you think? And why do you think it's false? Okay, so false, and he says because it should be positive 5 and negative 7. So first, let's just evaluate this. 5 and 7 are solutions to that. Like if they're solutions, they should be able to be plugged in and make it true. So I'm going to start by plugging in the 5. So me plugging it in would make it 5 minus 5 times 5 plus 7 equals 12. Class, what's 5 minus 5? What's 5 plus 7? 5 plus 7. Okay. And is 0 times 12, 12. So that makes it false, the whole situation overall. 5 is not a solution So we were right about it being false, but the reasoning isn't correct right now. It's false because it doesn't make the equation true. Neither of them do actually. If I were to plug in the 7, here's what it would look like. 7 minus 5 and 7 plus 7, which then becomes 2 times 14. Does that equal 12 when I multiply them? Okay, so those, neither of those are solutions. But where a lot of people kind of miss, and maybe they thought the same thing that Wade did, that is a common thought, it's supposed to be like that to kind of trick you. This isn't set equal to 0. So you can't apply that zero product property when it's not set equal to 0. So the solutions for that one, you'd actually at this level, I mean, we'll teach you eventually how to find it algebraically. But at this level, you'd have to just graph it and know where to look, which you weren't necessarily allowed to graph it in this warm-up. But I'm telling you right now, if you see that on your homework as of right now, where there's multiple x's that you cannot isolate, and it's not in factored form set equal to 0, the only way right now would be to graph it and look at the x-intercepts. Notice like this graph, all you see are 2 straight lines. You don't see any other features, no vertex, no y-intercepts. All you see are the x-intercepts. But luckily, since that's another word for solutions, you could still say what the solutions are and that they're not 5 and 7. All right, so good on this one? Questions? Okay, so let's make sure we're sitting up paying attention. I feel like some of us zoned out, but this warm-up hit a lot of key skills. So today, the title of the lesson is called How Many Solutions? So we've talked about how many different kinds of solutions quadratics can have. Today, we're going to use graphs to investigate that when they have 2 solutions, 1 solution or no solution. You need to be able to explain why dividing a variable to solve a quadratic equation is not a good strategy. That's directly related to a question on the constructive response test. So in order to explain why something wouldn't be a good strategy, you probably want to know how to solve it correctly. And then you need to be able to know that quadratic equations can have no solutions and explain why there aren't. I'm recording right now, but the lesson is there from last year, so there's no reason to be behind. You can always get ahead too. The practice is in Schoology, lesson 5. And this assignment I've talked about before, but I just want to remind you, last week we did some ACT exemplar tests, and you may or may not have lost points on them. This would be a great way to redeem yourself. It'll apply as extra credit assessment points based on how well you do. And it's basically a retake for that exemplar test. So it gets you extra credit, it makes up for lost points, and it'll help prepare you for your ACT Aspire math, which is not tomorrow. Tomorrow is your ELA tests for ACT Aspire. Your ACT Aspire math is next week on Wednesday. So Friday, you will have a quiz in here for what we've covered so far in Unit 7, and then you'll have your Aspire math the Tuesday. All right, but any questions? Okay, so then let's do the next activity, which is making you graph it. So I told you, like on your test, it's not just going to ask what are the solutions all the time. So, I mean, don't just rely on graphing, but this time it wants you to graph them to solve them. So do that. Graph each of these, know where to look for what the solutions are, and then answer these follow-up questions. So why might it be helpful to rearrange each equation to equal 0 on one side and then graph the expression on the non-zero side? And how many solutions does each of the three equations have? Again, you're solving by graph. And you have about 3 to 4 minutes because graphing doesn't usually. Table 1, can you tell me what the solutions are for that first equation? 3 and 5. And again, it said by graphing, so nobody tell me you can't type something into Desmos and know where to look. Because what's another word for solutions? X-intercepts. And really, when you do graph it, the way that it looks, all you see are 2 lines and they go through the X-intercepts. So yes, it's 3 and 5. Technically, for this one, you didn't have to graph it because it's in factor form and set equal to 0. So we've learned how to identify those answers really quickly. But yes, those are the 2 answers. Table 2, what are the solutions for the second one? 4, any others? Okay. Now, I don't remember if I told you guys this, but this that I'm writing, these aren't like parentheses, so this isn't a coordinate. These are like fancy braces. So whenever we use them, we're basically saying that X can be these numbers and nothing else, like we're listing them. So these are my solutions so far. And table 3, what are the solutions for the third equation? No solution. And what do you see when you graph it? You don't see anything when you type in this whole equation. We'll see them here in a second too. But those are all right. Questions on that? So when it says, why might it be helpful to rearrange each equation to equal 0 on one side and then graph the expression on the non-zero side? Well, hopefully we know what that means, like the vocabulary used there. Rearranging to where it's equal to 0, no matter what it is. So take like that first one that's already set equal to 0. Here's what it looked like when you first solved it. Right, so you just see the straight lines when you do that. And it's already set equal to 0, so I don't need to rearrange anything. But they're saying, like, why might it be helpful to graph the non-zero side? So here's what it looks like when I graph the non-zero side. So basically this side. Why is that helpful? What is different when I graph the 2? I mean, they're both shown on the screen. What's the advantage of the green graph over the blue graph? So why might it be helpful to rearrange it to set it equal to 0 and then graph the non-zero side? What is different? Well, that is true. Like there is an equal sign here and there's not an equal sign here. Why is it like it produces a different graph? Why is that helpful?
More clear with them.
And not just answers for like the x-intercepts, but sometimes you need in your test question, sometimes you need the minimum, sometimes you need the maximum, sometimes you need the y-intercept. Sometimes you need like a random point on the line for like when x is 9, what's the answer? So you can get all of that from this green graph, because you can see the U shape. And I see the U shape when it's written as an equation. So that's why. So you can put that in your own words for why might it be helpful. But that you can see the U shape better or whatever will make you understand it. So you can see the U shape more clearly. So if all you need is the x-intercepts, then the other one is perfectly fine. It only shows you the x-intercepts. But if you if you need the vertex, if you need something else other than an x-intercept, then that way of rearranging it, making it equal 0, will show you the U shape on your graph. So that one was already set equal to 0. Let's look at the second equation. How can I make this right side become 0? You could add 1. Now, whatever you do on one side of the equal sign, and now you don't have to do anything too crazy. I mean, you really can't. My left side is just now going to have a +1 on the end. And then now my right side is equal to 0. That's what they mean by rearrange it to equal 0. Now I'm going to graph it and see what it shows me. So let me put what it was before when you answered the previous question. Right, that was this equation. This is what it was when we rearranged it to equal 0 so that I don't have to put the equation in. And now look, it still has the same solution. It still goes through the x-intercept of 4. But with the green one, you can see all the other details more clearly. The blue one only shows you the x. Good? Okay, and then that last one. What would I have to do to this -4 to make it equal 0? Add 4. And then whatever you go on one side, do to the other. If you graph this, x minus 5, x minus 3, and add 4 on the end. So first, here's what you started with to see what the answers are. The blue, you don't even see it all right now. This is what we just talked about. If we rearrange it to equal 0 and only graph the non-zero side, you can see the U shape clearly. So right now, I can't see the blue at all. There's no line going through any x-intercepts. So what does that mean about the answer? If solutions are x-intercepts and it doesn't touch the x-axis at all, what is my solution? No solution. So you have to be able to recognize it. If you didn't have that green line to see, if all you did was type in that and you don't see anything, and like usually there will be an error message if there's an error. There's no error. You just don't see anything. Then it's a no solution. Right? Or to check, you could rearrange it like we just said, and now you see it doesn't touch the x-axis at all, so there's no solution. All right, good. Questions, comments, concerns? All right, so that, to answer the next question, how many solutions do each of these have? Well, the first one has 2 solutions. We'll never have more than 2 for quadratics. The second one has 1 solution, and that was where the vertex touched the x-axis and nothing else did. And then you could have no solution, and it doesn't touch the x-axis at all. On your problems that they say to solve in that next situation, I'm gonna have you skip to number 5. Because normally on a longer day, if we did this, I'd have you try them all yourself. And then we go over the answers. But for now, I want you to just look at number 5, this one. And let's solve it algebraically. So I can tell you 1 and 2, you should be able to solve by isolating. 3, you should be able to solve by the zero product property. 4 and 6, the only way you'd be able to solve these is by graphing because they're not set equal to 0. And you can't use the zero product property. But 5 is a unique situation. So let's look at that. Let's try isolating it. What's farther from the x, the 2 or the 1? The 2, what's opposite of squaring? Whatever you do on one side of the equal sign. And what is the square root of -4? And I take the square root of -4. So because I cannot square root a negative, then what does that mean about this solution? So this is what it looks like algebraically if there's no solution. On a graph, it wouldn't touch the x-axis at all. But algebraically, when we're solving, if it's trying to make you square root a negative number, you know to kind of just stop there and there's no value of x to make it through. All right, so that's all we have to cover today. Do your practice on your own. Make sure you get a good night's sleep. Make sure you get here early tomorrow so you know where to go.